In this video, I'm going to quickly run through the section B of this 2024 Mathematics Exam 2. And you can see you have totally 2 hours for writing, 15 minutes for reading. But today, I'm just going to focus on section B of this paper, okay? And I'll bring up my CAS calculator. All right, so let's have a look at section B. 60 marks. Answer all questions in the spaces provided. Responses in English. Wherever a numerical answer is required, an exact value must be given unless otherwise specified. In questions where more than 1 mark is available, appropriate wording must be shown. Okay, so this clause here, if they don't tell you round your answer correct to some decimal places, just give them thirds or whatever it is, okay? And questions where more than 1 mark is available, appropriate wording must be shown to guarantee the method mark or whatsoever. And unless otherwise indicated, the diagrams in this book are not drawn to scale. Okay. So basically, if you look at this question 1, it started with a function here. X plus 1, x plus a, x minus 2, x minus 2a. This is a quartic function. Part A, we want to find the values of x in terms of a where required for f of x equals to 0. Part B, we want to analyze the possible values of a for which the graph of f of x to have exactly 3 x-intercepts or exactly 4 intercepts. So in the structure of this function, you can see there are 2 known or fixed values, 2 and a minus 1. So the only uncertainties will be x equals to minus a and x equals to 2a, okay? So that's why you need to be aware of the uncertainties. Maybe you want to use sliders, but what I'm doing is I'll start with defining this function. X plus 1 times x plus a times x minus 2 times x minus 2a. And then if I use the button zeros, f of x, comma x, I'm able to get a 2a minus 1, 2. And also, let's say if I have exactly 3 x-intercepts, see what happens. First of all, I could just get, let's say, 2a equals to a. So a equals to 0. So f of x given a equals to 0. Now, it has 3 distinct factor parts. This is a repeated solution. This is a distinct linear factor. This is another distinct linear factor. Yep, a equals to 0 could be one possible case. And also, if I equate 2a to, for example, minus 1, see what happens. A equals to minus half. So I can sub this back to f of x. And you can see there are 3 different solutions, okay? 3 different solutions. Also, I can just equate 2a to 2. So a equals to 1. But a equals to 1 only gives us 2 solutions, okay? So we must not take a equals to 1 for 3 solutions. And another case is if I have, let's say 2a equals to 2, a equals to 1. We could have a equals to 1, yeah. And let's say if a equals to minus 2, let's say minus a equals to 2. What happens with this one? F of x given a equals to minus 2. Okay, so we actually went through all these possibilities, okay? All these possibilities. And pretty much for 3 solutions, a equals to minus 2, a equals to minus half, and a equals to 0. And just notice a equals to 1 is going to be the value for exactly 2 solutions, okay? I'm going to put this aside and summarize it here. Okay? The values of a for which the graph to have 3 intercepts. My working out, let's say 2a equals to a gives a equals to 0. So f of x equals to x squared, x minus 2, x plus 1. 3 solutions. And then I have 2a equals to minus 1. That gives me a equals to minus half. And this results in f of x be, let's say, okay, half x minus 2, x plus 1 squared, and 2x minus 1. Still 3 solutions. And then if I have a equals to 1 or 2a equals to 2, giving me a equals to 1. And that actually gives me f of x equals to x minus 2 squared, x plus 1 squared. 2 solutions. Nope. And finally, I have a case where a equals to minus 2, for example. That gives me f of x equals to x minus 2 squared, x plus 1, and x plus 4. 3 solutions. So overall, a belongs to minus half, 0, and a minus 2, okay? And then for exactly 4 intercepts, we need to exclude the above 3 values plus 1, okay? Because if I don't take all these 4 a values, then for everything else will result in 4 different distinct linear factors. A can be anything R except for minus half, 0, 1, and a minus 2. Okay? So altogether, we need to exclude 4 values. Next page. Let G be the function where a equals to 1. Yep, this is one possible case. We want G dash of x, local maximum of G, values of x for which derivative is greater than 0. And then we would like the 2 tangent lines at these 2 x values respectively. Then we want to find the point of intersection. So I'll then insert another page. G of x is assigned to x plus 1 squared times x minus 2 squared. So if I do shift minus, yep, that is the derivative function. And then coordinate of the local maximum of G. If you do a quick sketch, G of x, it's over there. So it's between, let's say, minus 1 and 2. And I'm going to do f max G of x, comma x, between minus 1 and 2. And then substitute to get the coordinates, 81 over 16. Next thing is if I solve the derivative greater than 0 for x, I should be able to get 2 sets, and I convert them into the suitable, let's say, suitable form, okay? Suitable interval form. And lastly, I've got the 2 x values for the tangent line. So let's call this y1 is assigned to menu 4, 9. G of x, comma, x equals to 1 take away square root of 3 divided by 2. So this is the first equation. And then I just bring this down and put the y2 here and make this plus. So I should be able to get another equation. And I just need to solve simultaneously. Y equals to y1, y equals to y2, comma, xy. So you should be able to get the coordinates pair easily, okay? All right. So that's a quick rundown to every part using the CAS calculator. So let's get back. Finish this part. G dash of x. I'm not just writing down the right-hand side expression. I always start with the correct function name and equal sign, okay? 2 lots of x minus 2 x plus 1 and 2x minus 1. And then we say use f max over minus 1 to 2 gives x equals to half. So the local max is at half 81 over 16. Okay. And find the values of x for which g dash of x is greater than 0. So for example, if I go for the CAS calculator, I have minus 1 less than x less than half, or x greater than 2. So in interval notation, I should write x belongs to round bracket minus 1 half union 2 to infinity. It has to be a union here. If you see the connecting word for two inequalities is all, you have to use union, not intersection. And then finally, let's write down the two tangent lines. Y tangent 1 of x equals to 3 root 3x minus 3 over 4 bracket 2 root 3 minus 9. Be aware of the transcription errors. And a y tangent 2x equals to minus 3 root 3x plus 3 over 4 bracket 2 root 3 plus 9. And you say solving simultaneously gives x equals to half, y equals to 27 over 4. Okay? All right, so that's what you need to write down. And the next part, let g remain this function for all real values, which is the function for f where a equals to 1, and h be the function like this, x plus 1, x minus 1, x plus 2, x minus 2. And we would like to do some transformations. Part 1 says using translation only. Translation means only the movement, left, right, up, down, okay? And the second part says a dilation and the translations. So the first part, we want the sequence of transformations of H. So this is my original, okay? And it would have the local maximum at the same coordinate as that of G. So once I do the translations properly, I can make the translated function to match the local maximum, but just one point matched, okay? So if you look at the diagrams, what I'm going to do is I'll also assign another graph. Let's say h of x is assigned to x squared minus 1 times x squared minus 4. Okay, basically that's the 2 expanded form. And I can just get this is g of x, and then this is h of x. So you can see the maximum turning point of h is at a 0, 0, okay? 0 at x equals to 0, y equals to 4, not 0, 0, bear with me. Analyze graph, maximum 0, 4. And the other point we found before was half 81 divided by 16, okay? So we can just move up by half to the right and then find the y value difference between the two coordinates, okay? So let's say 81 divided by 16 minus 4, 17 over 16, okay? So we say translation by half unit to the right. And then a translation by 81 over 16 minus 4 equals to 17 over 16 units upwards. Okay? So the problem is solved. And then the second part says using a dilation and a translations describe a different sequence of transformations for H, for which the image would have both local minimums at the same coordinates as that of G. So I need to look at the graph again. If you notice the difference, okay, so the blue graph would have 2, 0 and a minus 1, 0, okay? Minus 1, 0. Let me do that again. So the horizontal distance is, it's a 3 unit, okay? But as for the second graph, if I want the minimum, I probably need F minimum, H of x, comma x. So you can see this two absolute minimum turning point will be at x equals to plus minus root 10 over 2, which means the distance between the two minimum will be root 10, okay? Gap on H between two minimum equals to root 10 over 2 minus negative root 10 over 2, which is root 10. And gap on G of x between two minimum stationary point equals to 3, okay? So I would like some dilation. Let's say I want to dilate this number root 10 to 3, okay? A horizontal dilation factor of 3 on root 10. So this is the first thing involved. Let's say dilation factor of 3 over root 10 from the y-axis. Or actually, you could say from the h-axis, from the vertical axis, okay? But it's a horizontal stretch, okay? This one is wider, this one is narrower, okay? And then let's see what happens. Okay, once I get another graph, I don't need this much. Let's say minus 4 and a 4 here. Let's say h of x divided by, actually you can type square root of 10 divided by the 3, okay? So now I can just look at, okay, what happens with this black graph to the blue graph. Then I can take a horizontal movement and then the vertical movement. Let's say minimum on this graph. Oh, minus 1.5 to minus 2.25. So we can just shift everything by, for example, half unit to the right, then 2.25 units up. Say, if I go back here, bracket, x minus half plus 2.25 is 9 over 4. And you can see, yep, this black graph will match exactly, I'll delete this point. It will match minus 1, 0 and a 2, 0 here. But the difference is the two graphs will have a gap. The maximums do not match, okay? So this is what we found. So we have a translation by half unit to the right. And then translation 9 over 4 units upward to match, to match the two minimum turning points. All right, so pretty much that's question 1. Let's have a look at question 2. Question 2, we have a model for the temperature in a room in degrees Celsius. Is given by f of t equals to 12 plus 30t between 0 and 1/3 equal signs, and 22 if t is greater than 1/3. And we would like to express the derivative of f dash t as a hybrid function. We can do it by hand, but just be mindful. When you differentiate a hybrid function, you have to exclude the endpoints, okay? For example, the first bit is just 30 between 0, 0 less than t less than 1/3, okay? And the second part has 0 because you are differentiating a constant. So it's still t greater than 1/3, okay? And if you trust your CAS calculator, for instance, this time I'm going to insert another problem for the second question. F of t is assigned to a hybrid function, 12 plus 30t. 0 less than or equal to t less than or equal to 1/3, and then 30 t greater than 1/3, and then you can simply take the derivative f of t, and you can see these are equal signs are excluded, okay, because at the end point it's not differentiable. But if you read the assessment report published on VCAA website, they actually accepted an equal sign here because they wanted the initial instantaneous rate of change to exist, but you don't have an equal sign at a 1/3 here, right? You must exclude that. The derivative is not continuous at a 1/3. And then the question wants the average rate of change. So you say, okay, between 0 and half, f of half minus f of 0 divided by half. And should give you 36 degrees Celsius per hour, if I'm not mistaken. Let me just double look. Oh, no, actually, bear with me. I actually typed in the wrong equation. It has to be 22 here. Even though it doesn't influence my derivative, it does influence my average rate of change. So you have to be very careful. I was influenced by this number 30. Actually, this should be 22, okay? So let's fix that. Fraction, f of 0.5 minus f of 0 divided by 0.5, 20. That looks much better. Delta f divided by delta t equals to f of half take away f of 0 divided by half take 0, 20 degrees Celsius per hour unit, okay? And another model is this exponential function, 22 minus 10 e to the power negative 60. We would like the derivative of g dash t. You can do it by hand very easily. G dash of t equals to 22 becomes 0, minus 10 times negative 6, 60 e to the power negative 60, okay? And find the value of t for which g dash equals to 10. Give your answer correct to 3 decimal places. So if I do g of t is assigned to 22, take away 10, exponential minus 60. Derivative, g of t, t, yep, 60 e to the power minus 60. And then solve this equation equal to 10 for t. Natural log 6 over 6 rounded to 0.2986, etc. T equals to 1 over 6 log e of 6. T is rounded to 0.29. If I use the round button to 3 decimal places, this is where you need to be careful. 299, okay? T represent the time in hours. It's implied, okay? But let me just put hours here. All right, let's see the next one. Find the time between 0 and 1 when the temperature predicted by the models F and G are equal. Give your answer correct to 2 decimal places. And find the time t between 0 and 1 when the difference between the temperature predicted by the two models is the greatest. Give your answer correct to 2 decimal places. So what I'm going to do is first, I'll solve f of t equals to g of t, comma t. You will see there is a 0 and a 383 something. Well, this one may look too large and a 0 is not included. So probably you can give a smaller domain restriction, 0 to 1. And you can see there is another value. So if the gap is too large, your CAS calculator may not be able to solve it or search for it accurately. So you have to get this value. So it's t equals to 0, knock out, and t equals to 0.26560, which is rounded to 0.266. Actually, 27, 2 decimal places. 0.27 hours, okay? And we would like the time when the difference between the two temperatures predicted by the two models is the greatest. For the difference, physical difference, I would use, let's say, an absolute value function, because sometimes the first function is larger than the second. For other times, maybe the second function is larger than the first. So using the absolute value will avoid this issue. ft minus gt, and then I use f max, d of t, comma t, between 0 and 1. So you get a t equals to, for example, 1/3, okay? 0.3333, etc. And if you look at the diagram, f of x, g of x, see if I can get a very reasonable diagram between 0 and 1, minus 1. Let's use a larger value, 40. See, you can see between 0 and something like a 0.0 and a 0.27 something, there is a gap, but the red graph is higher than the blue graph. After this intersection, the blue graph is higher than the red graph, etc. And it's eventually asymptotic to the 22, okay? So if you want to search for the maximum, d of x, you can actually compare what's happening. Maximum, this graph, and also this graph. So you have to be very careful. Like this value, well, it's less than 0.333, but the distance value they generated is actually larger than 1.35. So I would say 0.11 is the suitable answer rather than 0.33, okay? All right, so this one is a nice one. So you have to think about it and look at the graphs more carefully. Okay, the amount of power in kilowatts used by the heater T hours after it is switched on can be modeled by the continuous function P, whose graph is shown below. P of T is 1.5 between 0 and 0.4, which is a horizontal line here. And another part is an exponential function, 0.3 plus a times e to the power negative 10t for t greater than 0.4. This is a continuous function. That means at this sharp point, same pt value, okay? And given that p of t is continuous for t greater than or equal to 0, show that a equals to 1.2 times e to the power 4. So we would like p of 0.4. to exist. Therefore, 1.5 equals to 0.3 plus a e to the power minus, let's say, 4. When you sub in t equals to 0.4. And then you have ae minus 4 equals to 1.2. So a equals to 1.2 times e to the power 4 as required. You just multiply both sides by e to the power 4. Problem solved. For this to show that question, I believe you need to show the clear substitution to form an equation and 1 or 2 steps rearranging into the answer. And find how long it takes. By the way, there is another short sentence you should be aware of. The amount of the energy. This is the power, the rate of energy, okay? And energy itself in kilowatts hours, like a power multiplied by time hour gives you the energy. So it's evaluating the area between the graph and the t-axis. So the area under this graph gives you the energy. Like up to a certain point, for example, let's say it's a particular time tc here. This area of rectangle will give you 0.5 kilowatts hours of energy. That means, okay, tc times 1.5 equals to 0.5. Therefore, tc equals to 0.5 divided by 1.5, which is 1/3. In this case, the question did not give us any rounding instruction. That's why you need to write exact answer. Not like the 2 questions before. They ask you for 2 decimal places, 3 decimal places, okay? And find how long it takes after the heater is switched on until the heater has used 1 kilowatt hour of energy. Give your answer in hours. Now you need to round it correct to 2 decimal places. Well, do a quick estimation. Up to the rectangular area, this rectangular area say, okay, the width is 0.4, the height is 1.5. When you multiply them together, you should be able to get, for example, 0.6, okay, 0.6. But the 0.6 is not yet 1 kilowatt hour. That's why you still have some curvy area afterward, okay? So this bit is like a 0.6, and then the rest will give you, let's say, 0.4, okay? Maybe somewhere here. Okay, use the diagram. That's why you need to form an integration. So 1.5 times 0.4 plus from t equals to 0.4 to a time a after the heater is switched on. We say the equation was 0.3 plus this a value times e to the power minus 10t. 0.3 plus e to the power 4 times e to the power minus 10t dt equals to 1. So this is a method, like you show the appropriate equation, establish this integral equation and solve it. You can solve 0.6 plus shift plus 0.4 up to a, 0.3 plus exponential 4 minus 10t dt equals to 1, comma for a. Does this sound correct? Let's have a look. Let me just double check. I don't feel it's quite right. 1.5 times 0.4. Hold on a second. Let me have a further look at this one. Okay. Seems that I missed the constant before. Let me just double check. Oh, 1.2 e to the power 4. Yep. Hold on, times 1.2 here. That's the a value. Should have a 1.2 here. That's why you would say, 1.2. This answer looks much better. So the time a, 1.333, 1.33 hours. Yep, that's the problem solved, okay? Should have put this 1.2 here. All right. So just be aware of these small transcription errors. Question 3. The points shown on the chart below represent monthly online sales in Australia. The variable Y represents sales in millions of dollars. The variable T represents the month when the sales were made, where T is equals to 1 corresponds to January 2021, T equals to 2 corresponds to February 2021, and so on. So now I've got a function like this. It's a cubic graph in terms of T. It has a local minimum at 2,500 and 11,400. Remember, whenever you see this term, local minimum, local maximum, it also indicates the derivative at this T value must be 0. There are 3 marks to find the A, B, C, D. So probably with these 2 pair of coordinates, you can form 2 equations. And also you need to derive this equation. And subbing 2 equate to 0, subbing 11 equate to 0. So what I'm going to write is like this. P of 2 equals to 2,500. And a P of 11 equals to 4,400. Also, P dash of 2 equals to 0, and then P dash of 11 equals to 0. They only provided you, let's say, 6 writing lines. But you can leave your answer like that as long as you define your P dash T equals to 3AT squared plus 2BT plus C, okay? What I'm going to do with my CAS calculator is I will say insert a problem, add a calculator. P of T is assigned to A times T to the power 3 plus B times T squared. You need to have a multiplication sign here, plus C times T plus D. And then I would define a dP of T, which means the derivative shift minus T, P of T. This is easier to do the substitution. Then I just carry out a solve. P2 equals to 2,500. P11 equals to 4,400. dP of 2 equals to 0. dP of 11 equals to 0, comma A, comma B, comma C, comma D. So you should be able to get some exact values, but then they just ask you to round them to 2 decimal places. So each of them will be just solving simultaneously. A equals to minus 5.21. B equals to 101.665 actually. Be careful with the rounding. 6 round up, okay? C equals to minus 344.03. And D equals to 2823.18. Okay? All rounded. Next thing is if you notice location of local mean and a local max. Part 2 says Q of T is equal to P T minus H plus K. Another cubic function obtaining by translating P, modeling the monthly online sales in 2022. Find the values of H and K such that the graph has a local maximum at 23,450. So the old maximum was at 11,400. The new maximum is at 23,450. Basically, it's a translation by 12 months to the right, and a translation by $350 million up, okay? The nature of the stationary point doesn't change, and the format of this equation, translation only. That's why we say, okay, H equals to 12, K equals to 350, if I'm not mistaken, okay? And then From part B, another function f can be used to model monthly online sales where f is between 0 to 36. F of t is 3,000 plus 30t plus 700 cosine something plus 400 cosine something. And a part of the graph is shown below. We would like to complete the graph of f on the set of axes above until December 2023. That is for t belongs to 24 to 36, which means I'm going to start from here and draw another pattern, okay? Label the endpoint at t equals to 36 with its coordinates. So just be mindful, this bit is like a linear trend plus a circular function trend, okay? So there is a trend line. And if you use a ruler here, can you see my ruler here? This bit. This is actually showing you some trend line, and the turning points seems to touch the trend line, okay? But this is not required to sketch the trend line itself. We want it to complete the graph. So what I'm going to do is I will just put another new problem. Actually, you don't need a new problem. You can go back to the original express control doc, add graphs. So first thing, I will change this to 36. And I'll change the top number to be 6,000. Then I just type in the equation. 3,000 plus 30x plus 700 cosine of pi times x divided by 6 plus 400 cosine pi times x divided by 3. So you can see there is a third part, okay? And if you type in f1 of x between 24 less than or equal to x less than or equal to 36, it will show you the specific part you are required to find. And then I just need to find out the coordinates, okay? So roughly speaking, if you get your locations of these points correct, you should be fine. Page layout, select layout, layout 3. And I'm using f1 of 36, which is 5,180, okay? 5,180. So I'll place my CAS calculator on the side and give you some indications, okay? Let's use the full picture. Bear with me for a second. Maybe I can just use the handheld only. Okay. So I'm going to put a point like here. 36, 5,180, okay? Now, to get a clear understanding of what's going on here. Some graph like that, okay? Of course, for better accuracy, you could locate the other 3 turning points with their exact decimal locations. But I just do the exactly what's required by the question. Okay, let's move on and look at the next few parts. The function predicts that every 12 months, monthly online sales increase by $N million. Find the value of N. Basically, if you look at the graph here, well, you could say F1 of 12 minus F1 of 0, it's 360. Or F1 of 24 minus F1 of 12, 360. So this is called a seasonality change, okay? Seasonality, some sort of seasonality, I would say, if that's a correct term. $360 million. And I find the derivative f dash of t. So we say shift minus. Notice that I already defined or plotted f1, but I'm not going to use x. I'm using t to make sure a consistent letter change. So I would say f dash of t equals to minus 400 pi over 3 sine pi over 3t minus 350 pi over 3 sine of pi t over 6 plus 30, okay? So that is the derivative function. And hence find the maximum instantaneous rate of change correct to the nearest $1 million per month and the values of t in the interval 0 to 36 when this maximum rate occurs, correct to 1 decimal place. So what you can do is you may want to try f maximum, this function, comma t, comma 0 to 36. And you can actually find the 3t values, 10.24 or 10.2, 22.2, 34.2, and it occurs periodically, okay, for each 12 months. So we say when t equals to 10.2436, 22.2436, and 34.2436, rounded to 10.2, rounded to 22.2, rounded to 34.2 in month. The maximum rate, you can use either any one of them, but make sure you sub in all the digits. So I'm just dragging down the expression and sub this t-value in. Should be 698. Is that correct? Maximum instantaneous rate of change. Oh, actually, it's a 30. That's why you need to bring down the 0 as well. Okay. Oh, its max rate is approximately 725. Nearest, okay. $1 million per month. Yep, that should be the correct answer. The 3 t values between 0 and 36 and the maximum rate itself. Okay, so that's question 3. Let's move on to question 4. And an airport luggage is weighted before it is checked in. The mass of each piece of luggage in kilograms is modeled by a continuous random variable whose probability function is cubic. A piece of luggage is labeled heavy if its mass exceeds 23 kilograms. A definite integral, luggage labeled as heavy. So we say 23 up to 30. You couldn't actually have a piece of luggage with infinite weight, okay? And I just copied out 1 over 67500 x squared 30 minus x dx, okay? The question wants a definite integral, so I'm not going to calculate this thing. But for the mean, for the standard deviation, and also the probability question, I have to use a defined function. In that case, I'm going to use the new problem. Let's just say f of x is assigned to x squared times 30 minus x, 67500. And then the mean value is shift plus 0 to 30, x times f of x dx. It's 18. And the standard deviation is finding this thing, x minus 18 squared times f of x integral. This will give you the variance, and then the standard deviation is just 6, okay? So ex equals to integral 0 to 30, x times f of x equals to 18 kilograms. And variance of x is 0 to 30, x minus 18 squared, f of x dx, which is equal to 36. Therefore, the standard deviation x equals to 6 kilograms. The unit for variance is kilograms squared, but you are not required to write down the unit. Next thing is, given that the mass of piece of luggage is more than the mean, so it's a probability statement, x is more than 18. Find the probability that it is labeled as heavy, so greater than 23. Okay, And this probability statement will give you, let's say, 23 up to 30 divided by probability 18 less than x less than or equal to 30. And it's the ratio between two definite intervals. So you could say 23 up to 30 f of x dx. Now, because you're calculating the area under the curve for the probability, you don't have to multiply x or multiply x squared. So just be mindful. And then 18 to 30 f of x dx. Sometimes student could write 18 here and 23 here, but be mindful. This bottom integral has a larger span, therefore resulting in a larger area, the denominator, okay? So just be careful. What you're going to do is do this one, put the 23 here, delete the x, and also divide it by, you press Control, divide, and then Control V again. Then put an 18 here. So this is the exact value, and this is the decimal value. So it's roughly 0.446, okay, if I'm not mistaken. Yep, that's pretty much this first page of the probability question. Then if you take a look at another page, this is a very interesting one because of the travelers flying from the airport, 10% do not checking any luggage. So if they do not checking any luggage, there is no possibility for them to take in to checking a heavy luggage whatsoever. 40% checking exactly one piece of luggage, 50% checking exactly two pieces of luggage. So could be heavy, let's say H, and not heavy. That's N, okay? If they check in two pieces of luggage, you could have heavy, 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 light, light, heavy, light, light, okay? So there are different combinations you need to be aware of. And if they check in, let's say, two pieces of luggage, W is the discrete random variable representing heavy luggage. So if you look at the bottom half of the page, you can draw a possible tree diagram. No luggage, one luggage, two luggage, 0.1, 0.4, 0.5. And one luggage, let's say heavy, 0.234, 0.766. And a two luggage, let's say heavy, heavy, light, 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 and then heavy, okay? So pretty much this is a tree diagram you could make use of, okay? And we want to use probability W equals to 2 is probability two luggage first, then heavy, heavy. That's why you need to multiply by 0.5, then 0.234 times 0.234. And then you calculate and get roughly 0.027, etc. Okay? And for this 0 and 1, well, you have to be careful. For two luggage, it's actually, this branch is a binomial distribution for all the combinations and permutations, all the possibilities. For zero heavy luggage, you could have this bit, 0 heavy. Probability 0 heavy equals to 0.4 times 0.766 plus, let's say, not heavy, okay? And you could get, let's say, plus 0.5 times 0.766 squared, okay? Something like that. Let's just do this one. 0.4 times 0.766 plus 0.5 times 0.766 squared. So you get something along this line. If I missed anything, shouldn't be. And then you could get, let's say, 1 take away 0.027, take away this bit. Let me just double check all the possibilities. 0.234, 0.234, 0.766, 0.766, 0.234, 0.766. Oh, actually, I also need to include the 0.1. Almost forgotten. Because no luggage means no heavy luggage as well. So eventually, the answer should be this bit plus 0.1, which is 0.699778. If I round this to 3 decimal places, it's 0.700, okay? 0.699778, rounded to 0.700, okay? And then for the rest, I'm just doing a 1 subtracting 0.7 minus 0.027. That would be 0.273, okay? So in fact, if you take a closer look back at this whole question, it's just a different question. It's not an awfully challenging question. Sometimes for the so-called challenging probability questions, your best bet will be a tree diagram, okay? A tree diagram. Okay, part D. 35 pieces of luggage selected on the airport, labeled as heavy. Okay, so we still assume P equals to 0.234, the probability of a single luggage being heavy. And then M value is 35. Let's call this Y is a binomial 35, 0.234. And then probability of P hat. P hat equals to Y divided by 35. Therefore, you are calculating Y greater than 0.2 times 35. And this is giving you probability Y greater than 7, which is probability of Y greater than or equal to 8 because Y is a discrete, but it's less than or equal to 35. Then we use a binom CDF. Binom CDF 35, 0.0234 from 8 to 35. And it should be able to get 0.595, 3 decimal places. Okay? And determine the probability that P hat lies within 1 standard deviation of its mean, correct to 3 decimal places. Do not use the normal approximation, so you have to use binomial. Basically, you can convert the P hat values to Y values, okay? Well, what I'm going to do is I will just calculate the following things, okay? I'll just calculate the following things. For example, 0.234 subtracting square root 0.234 times 0.766 divided by 35. So this is the lower bound. And then if I change the minus to a plus, it's an upper bound. So 0.234 is the mean of the random variable P hat, the population proportion. Subtracting 1 standard deviation, add 1 standard deviation, and then I will multiply both values by 35. And then, because once I multiply the P hat values by 35, I'm converting them into the Y value, which now should only take whole numbers. So it's going from 6 to 10. So we are calculating binomial CDF from 6 to 10. And I should be able to get a 0.684, okay? Correct to 3 decimal places. So this is what I want to show you. Lower P hat, lower band is 0.234, subtracting 0.234 times 0.766 divided by 35. Upper 0.234. plus 0.234 times 0.766 divided by 35. Then multiply by 35. So now we have a y between, let's say, 5.685 dot 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 less than 10.694 dot dot dot. Therefore, probability 6 less than or equal to y less than or equal to 10 gives you 0.68388. And it's rounded to 0.684, 3 decimal places. Okay. Part E1, in a random sample of 50 pieces of luggage, 10 are labeled as heavy. So the sample proportion p hat is 1/5 or 0.2. Use this sample to find an approximate 90% confidence interval for P, the population proportion of heavy luggage. Correct is 3 decimal places. This is an easy CAS exercise. Manual 6, 6, 5. So we have 10 pieces, X, 50 pieces, N. C level is 0.9, not 0.95, okay? 0.9, 90%. Press OK and Control Enter. Just copy the answers. 0.106, comma. Actually, 0.107, bear with me. Rounded are correct to 3 decimal places. And 0.293, okay? 0.293. And the second part, we need a second random sample, 50 pieces of luggage. And using this sample, the approximate 90% confidence interval for P, the population proportion of luggage labeled as heavy, is wider than the one obtained above in part E1. We would like to find the minimum and maximum possible number of pieces of luggage labeled as heavy in the second sample. So we would consider the standard deviation, standard error or standard deviation must be, wider than the previous one. What I'm saying is the old standard error is equal to 0.2 times 0.8 divided by 50, right? And for another sample, it's still n equals to 50. The new standard error. Now we write it differently. Let's say it's x divided by 50, and then 1 minus x divided by 50, divided by 50. If the second expression is larger than the first expression, it satisfies the criteria wider. That's why we say 2 larger than 1, and see what we can obtain. So we use the solve button, a square root. Let's say 0.02x times 1 minus 0.02x divided by 50 is larger than square root 0.2 times 0.8 divided by 50, comma x. And you will be able to see this is greater than 10 but less than 40. It has a strict inequality. 10 less than x less than 40. Therefore, if I take an equal sign into consideration, that's from exactly 11 to 39. So the minimum is 11. The maximum is 39. And that's the answer. So this is the last part of the probability question. All right, last part. Well, this is an interesting question because you can see it involves some composite function. F of x is sine x, gx is sine 2x. So firstly, we look at the gfx. Then we specify the range. And we need a local maximum whatsoever. My approach is to insert another menu problem and then just define them as it is. F of x is sine x, g of x is sine 2x. So now if I plot the first graph, let's say g bracket f of x. Of course, you don't need that much. You just need, let's say minus 2 here, 2 here, and then check this is 0, and then this is 2 pi, okay? So now I would like the local maximum lies within 0 to 2 pi. Oh, sorry, half pi. It's actually here. So just identify analyze graph maximum is 1. Easy busy, lemon squeezy. So it's 1 decimal place, 0.90334 dot dot dot, comma 1, exactly 1. So approximately 0.9. If you want to write 1.0, that's fine. But actually, this y value is exactly 1. So you don't have to write 1.0. And state the range of g of f between 0 to 2 pi. So you can see this maximum y equals to 1. Then the minimum y by symmetry is minus 1. That's why I would say it's minus 1 to 1 exactly. Okay? Believe it or not, because you can use manual analyze graph to look at the minimum. Yep, this is minus 1. Next, find the derivative of f of g. F of g. So now you can look at the second graph, f bracket g of x. Yep, and then just look at this bit. This is f2. So we can do derivative f2 of x comma x. Just copy this down. We say d dx f g of x. Notation-wise, I just write 2 cosine 2x times cosine of sine 2x. Yep. And it showed that the equation has no real solutions. Well, we are going to discuss this properly. For example, if cosine of sine 2x equals to 0, then sine 2x is going to be plus or minus half pi plus or minus 3 pi over 2 plus or minus 5 pi over 2, etc., etc. But the range of sine 2x is minus 1 to 1. None of the above values lie within minus 1 to 1. Therefore, no solution to this equation over x belongs to R. Okay? Just be mindful the plus or minus half pi will be plus or minus 1.57, etc., etc. Non-recurring, but infinite number of digits. But all of these values are outside minus 1 to 1, or you can just graph it. Let's say this is a sine 2x graph whatsoever. And this is 1, this is minus 1. And the closest two lies y equals to plus half pi and y equals to minus half pi. Okay, you can see they are outside the outside the range. So now if this part has no real solution, then I can only look at a 2 cosine 2x, okay? Because this is solving the derivative equal to 0. And the second part equal to 0 has no solution. By Naur factor law, I can only take 2 cos 2x equal to 0. So what I'm going to do is just equate this bit to 0 and even that 0 less than or equal to x less than or equal to 2 pi. Doesn't solve very well. Now, actually, you can just extract the last 4 pieces. Ignore the previous bit, okay? So x equals to pi over 4, 3 pi over 4, 5 pi over 4, and then 7 pi over 4, etc. And find the range f of g where x between 0 to 2 pi. Okay, so we can see this is pi over 4. This is 3 pi over 4. We need exact values. Notice the question does not give us any rounding instruction. What we're going to do is f2 of pi over 4. This is sine 1. And f2 of 3 pi over 4 is minus sine 1. So I'm going to say the range f of g of x equals to minus sine 1 and sine 1. We have to write it in exact form, square bracket. Towards the end of the paper, only 3 parts left. So we want to write a single definite integral that gives the area bounded by the graphs f1 and f2 over the interval 0 to 2 pi. So basically, if you look at the graph here, we can just state the area bounded first. Analyze graph, bounded area from 0 to 2 pi, if I'm not mistaken. Yep. More decimal places. So bounded area equals to 4.96911, etc. 2 decimal places, 4.97. Okay. And for part 1, we need a single definite integral. Basically, f of g is f2 and g of f is f1. So if you look at the two graphs, we need f1 subtracting f2 between 0 to 2 pi, then double the area. So we're going to say area needs to double one section from 0 to 2 pi. G f of x minus f g of x dx. If you look at the assessment report and the published marking guide, there are other versions, but I think this one is the easiest one we can come up first naturally. Okay, it's thinking about some symmetry, thinking about some basic simple values. All right. And finally, if I look at this part, f1 of x equals to sine x between 0 to 2 pi. Of course, we can take a smaller restriction bit. For example, find all values of x in the interval 0 to 2 pi for which the composition f1g is defined. How does that work? For f1g of x to be defined, we need range of G is a subset of domain of F1. Okay, so what is the range of G? Well, if you look back, G of x, this expression here, symbolically, it's the range. Whatever x value, you can calculate the y value, this is the range. So we have a sine 2x must be a subset of, for example, 0 to 2 pi, whatever it is. And notice your sine 2x can only be part of minus 1 to 1 because the maximum value and the minimum value of sine 2x. Therefore, truncate 0 to 2 pi intersecting minus 1 to 1. This will give us 0 to 1 only, okay? Now we can solve sine 2x less than or equal to 1, larger than 0. And then the x value, overall, we just discussed anything from 0 to 2 pi. So if I draw a diagram, this is one cycle, half pi to pi. This is pi to 2 pi. This is 3 pi over 2. And then the possible region, let's say 1 minus 1 from here to here for the x values, okay? From pi to 3 pi over 2. Then you have x belongs to 0 to half pi union pi up to 3 pi over 2, all round brackets, okay? Okay, I think that is my full solution to the section B of 2024 Mathematics Exam 2. And yeah, I use my CAS calculator where appropriate, but you can see I rely more on my mathematical understanding. So you need to practice both and focus on your real mathematical understanding. CAS calculator is just a tool of trade, but of course, you can see my TIS bar provides me a lot of help. I will do the multi-choice question walkthrough later. Hopefully that's helpful, and I'll see you in the near future.